My name is Talat. I'm going to the new catalog implementation in Iceberg. Last 1 month, I work on it, and when I submitted this talk, actually, it wasn't merged yet. Community was reviewed. If you read abstract, I mentioned that it's reviewing actively on community, but the Monday, the PMCs decided to merge now. It will be available 1.10. If you start using the new version, you will immediately see that. And in this talk, I'm going to explain that. First of all, I should say that I'm working for Google, and I'm leading the Iceberg effort in the Google, like inside of the BigQuery, and mostly on the open source side. And this talk is more related about that how we can bring the BigQuery engine and the Spark engine and the work on the same tables, and I will explain the reasoning. And I don't like to have a monologue. I usually like the discussions or questions in the while presentation. If you can help me for that, I will be really appreciate. Otherwise I will get nervous. Are these guys like my talk or those kind of things? Please don't make me nervous. Just ask the questions or participate. It doesn't have to be question. So far is good. Okay, thank you. Okay, today's agenda, I am not able to see that. Let me go here. Why we need a unified metadata? Basically, what we are trying to do that, yes, BigQuery catalog is an Iceberg catalog, but at the same time, for Google Cloud, we try to build a unified metadata, not just Iceberg and Hive and other engines like Spanner or BigQuery itself also too. And we are going to look at that, the reason. Then I'm going to show metadata access across the Apache Spark and BigQuery using the Apache Iceberg catalog. Then the small demo, it's not the rocket science. Just I will show that how you can use it. Then the Q&A part. I worked as a data engineer for a while. Since I remember my the history, I keep working with the Hadoop, Spark, and others. And most of the time, especially for the finance data and others, you don't want to give the access for everybody. You want to hide the company's customer's name or maybe some PII data you don't want to share around. Then usually what happens, most of the engines has their own catalog engine, own catalog implementation. If you want to share your data, you have to copy data without customer name or without a customer specific PII data. This causes a fragmented and multiple copies of the data. Iceberg is just get rid of this behavior because Iceberg become a table format for everybody. But if you are using a spanner and spanner doesn't support that thing, then you still have the same issue inside of your engine. The Iceberg is on the soul. Whoever supports Iceberg, but the unified catalog information is required for the other engines also. Yeah, as I mentioned that you don't want to share the customer's data, which means that this is a kind of you need a governance about the data. Who can access whole data, who can access partial data, or other use cases. Usually, data engineers are doing some kind of workarounds, building pipelines, like moving the data when it is written on the GCS bucket, just triggers another workflow on the Airflow, then they write some another place to give the access to engineers or the data analysts or machine learning engineers, those kind of people. And this causes also additional engineering effort, right? Then this is kind of the issue most of the time. If you want to build a product, you have to focus on the infrastructure a lot than rather than building your specific product feature. Let's imagine a use case. This is just totally imaginary. Like we have Alice, And she's a data engineer writing Apache Iceberg tables using the Spark. Not surprised, the Iceberg is, the born with Spark kind of, then she wants to share that table with Bob, who is a ML engineer using the BigQuery. And he just needs to query the data. He doesn't need to, to know all of the informations. Is this a common use case for you guys, or did you, have similar use case?
Apart from BigQuery.
Okay, if you're not using GCP, of course.
But I heard the data sharing complex side also because from back tech, they have the team. After that, I heard the Iceberg has the data sharing.
Yeah, exactly. I heard that also too. Okay. Go ahead.
Can you talk about established? Did you get the question?
Yeah, I think you can get it.
No, did you hear what I asked?
Yes, I got it.
Yeah, that was the end of my question.
Each engine has their own catalog, right? Then if you are using a Spark, if you're not using Iceberg, and if you use the Spark people, Spark also has the own catalog. It can be in memory. You can use Hive behind of the scenes to persist that information. Or if you are using PostgreSQL, like I am not saying that any data engine. The Postgres also has the own catalog implementation. BigQuery has own, or Spanner has another one. Snowflake has also own. That's why we are start working on, especially for GCP specific. I'm not saying that the multi-cloud support. We try to focus on how we can provide a unified catalog to our customers, then they can leverage one single place and make available the tables out of the engines. Is this answer real? Okay, let's dive into this use case. I may, emphasize multiple times, like unified metadata is just shared runtime metadata extending, and this means that whoever is available on, the GCP, BigQuery, Spark, the Flink, Hive, or your Java application or your Python application, you can use this unified catalog. This enables you to, you don't need to create exist data or copy the data and keep building the same pipeline again and again. You can governance your data just from UI, and you can say that, hey, this set of the users or group of the users should not access this column, or should not access the column ID, let's say, more than 10. And this group of the users should not see those roles. And as I mentioned, that centralized thing. And VQMS is also provide serverless experience. For Hive, for a while I used the Apache Hive. That's why I'm going to give that example. You have to maintain the Hive Metastore, and some DevOps guy has to look at the disk, the MySQL health and the connections, those kind of things. But the BigQuery Metastore is serverless. You don't need to think about that. Bye. Sure.
You said about the BigQuery and cloud storage. What's the performance difference? What's the performance difference between storing in a BigQuery storage versus cloud storage for Iceberg tables?
I don't know the exact performance differences.
Is it latency or throughput or the query engines processing? But they impact that. My question.
BigQuery is definitely, the design for own storage. I assume that I didn't run any benchmark. This is just my assumption. I assume that BigQuery is a little bit faster than the cloud storage, but at the same time, BigQuery support Iceberg tables, which means that you can use Iceberg table with the BigQuery on the cluster. And I don't expect any differences, but I'm not sure, I'm not saying that, because it depends on the query, it depends on the use case, and that's why I don't want to say anything else.
So one more question. Is this unified Metastore not just for analytical data, but also you're pushing Spanner metadata?
Yes, exactly. This is the effort overall GCP. Like, we will have a unified catalog for the BigQuery spanner and others, and they can leverage it or data prop.
And that's the source of truth. It's not a copy of.
Correct. Yes.
And where does the data prop Metastore stand in this part?
Can I give the chance to him and then I will go back?
Yeah, just a quick question on the terminologies. Could you define, or are they the same, the Metastore versus catalog terms? Are they one and the same? And kind of
They are same. The catalog is just an instance of the Metastore. We can Metastore can have multiple catalogs, and you can define a group of the tables under the one catalog, and the BigQuery also support data sets, which means catalog, data set, and table, and three of them stored in the Metastore.
Okay, so
Not the data.
So Metastore would be the superset, and then catalog would be one of them.
Correct. Yes. Metadata database. You can think in that way.
And in this kind of taxonomy, where would, as a BigQuery user, I'm pretty used to going to information schema tables, so that would be would that be part of the catalog, or information schema tables for the schema stores? Really?
No, information schema tables actually is the Metastore. You can think in that way.
Thank you.
Yeah, that's quite sorry.
Question on the trademark. I think it's all of them.
So with everything branded as a BigQuery Metastore, right, where does the Metastore service that used to be part of the data prop exist? Would it still be something bounded within the scope of data prop, or the Metastore here can be accessible from the data prop clusters, or how does that eventually the things get connected?
The name of the service is the BigQuery Metastore, but actually it's the serverless server, which means that it's not storing the data prop or BigQuery. It's a service you can interact with the client, and we keep your data inside of the server.
So I can still spin up my data prop cluster.
Yes, you can use it. Yes.
The diagram which you see, the BigQuery and storage, both are variable. BigQuery
For Metastore
on
perspective,
top of
yes.
the cloud.
BigQuery is, the BigQuery is yet another engine, and you can think that cloud storage is also a storage. BigQuery itself is a product has catalog, engine, and storage together. And that's why when I look at from the Metastore perspective, both of them is for Metastore is a customer. BigQuery is also a user.
BigQuery itself is a storage.
Yes.
And suppose all the open tools, any other open tool, those are created in BigQuery or in the data lake environment where that.
Correct, but those informations are stored inside of the Metastore, because Metastore is an abstraction for all of the engines. If you let me to go further, then you will understand. That's why I am going to do the demo.
Yeah, I have a somewhat an add-on question to that. I think, would you, like, if we have data in different regions, right, is that gonna be multiple Hive or Iceberg catalog, and then you have a unified catalog as globally? Is that how you are thinking about this?
We can think in that way, this is a Metastore as a web service. And think about that Hive doesn't need to store any information in Hive itself. And it can call our service and get the catalog information is for Hive expected format. Because each implementation like Hive, Spark has their own, the way to store the information. But the BigQuery Metastore is provides whoever is asking, like if Hive is asking to that information, turns as a Hive information. If Iceberg Spark is asking that, it just turns as an Iceberg.
So we would, I would use this, I'm thinking about it, I have to tag it myself as this is a catalog for US region, and this is one for the European region.
Yes,
Right, there's no other box functionalities you are thinking about that help to manage the region.
This is just, the recently we started implementing, that's why currently we only support the Iceberg. And hopefully we will expand our integration. Besides of the being new, there is no any limitation.
Got it. Thank you.
Okay, I will continue if everybody.
Exposed through Iceberg.
Oh, sorry. Okay, this is people are you were asking also the same thing, you know, the like in the Spark side, when a user say show databases or show table, actually behind of the scenes, Spark is just read the BigQuery Metastore, get the tables. But what it brings us, you know, the normally if you are reading a table, you don't have a control which table you allow the user. They can see or not see, right? They can see all of the tables because data is always there. In BigQuery Metastore, we provide a governance control, like table access, column level security. You can tell that this user should not see this column, and row level filtering, data masking, like they should not see the social security number, kind of informations. This BigQuery Metastore abstraction brings you to kind of data governance. This is the most important part, I believe. You know, if you have to share that data. Like our use case, Alice needs to share with Bob, but Alice can see all of the data, but Bob should not see the social security numbers. Right? None of the ML engineers require the social security numbers information. And at the same time, Spark can access the BigQuery tables directly to the BigQuery. Unfortunately, in here, you know, the thumbnail, but if you look at all the screens, you can see that BigQuery also can do the same thing. BigQuery is just, you can think in that way as a yet another engine. It can be Spark, BigQuery, or Flink, whoever use that. Okay, for demo, I will try to do live, you know, but if you have a question, I can take it. If you don't, you know, hopefully everything goes smooth, you know, this is my local machine, and I'm going to copy, of course, I'm going to copy the comments. Where is that? Open. I don't know. Okay. This is, yeah, I can use this. Let's try that. This is the other plan, blah, blah. Up here. There's a problem there.
Yeah.
Give me. Okay. I don't know. Let me check that. Get something is not supported. Oh, I know. Okay. Sorry for that. The ground breaking Java. Let me try again. And I will also explain what I'm going to do now.
Make the text a bit bigger.
Yeah, sure. I will. Is it good enough? Or okay. Okay, let me go back to presentation while it's open. When I start my Spark SQL, I am just, you know, passing the parameters for my Spark SQL to use the BigQuery catalog. And these are, you know, if you see that Spark.SQL is, you know, the common for catalog also, this first three. Then this is my catalog name. I can give any name, but, you know, to differentiate that, I just say BQMS, BigQuery Metastore _ catalog. Then I give my BigQuery project ID and the location of my project. These are, you know, the general cloud things. What is my warehouse, which is a bucket, and that's bucket under folder. And then I'm just telling that use the Spark catalog, and as a catalog type, use the BigQuery. Now I create my Spark engine. Yes, here. Now, what I'm going to do that. Okay. Let me copy this one. Okay, this. Let me say, the use catalog like here. Then Spark will use my catalog. Then I can say, the show namespaces. First, let's look at that show namespaces. As you can see that there is nothing, just only empty. Now I'm going to create an Iceberg namespace. Okay, now I will say show namespaces. Oh, it doesn't show me no namespaces.
Dot show. In chat, show.
Ah, yes, you're right. I'm sure that, yes, show. Yes, now I see the namespaces. Sorry for that, the first one, it should be empty. Second one, okay. And now I'm going to use my namespace, like use namespace. Okay, now let me show tables. And you can see that there is no table. You see that there is no table. Now I will create a table using the BigQuery. When I call the show table, now we have the table in here. I create this table in the Spark. And if I go my BigQuery UI, then if I refresh that, you should be able to see namespace, then the table, which is created by the Spark. And also, let me enter the data, and we can query from the BigQuery. And this correct table, insert into. Let me do this. Okay, not show. First row, because I have to do escape. Sorry, initially I thought I can do with Spark people. I didn't like the appearance, that's why I switched to Spark shell. This is, we inserted one row, and if you go to query in the BigQuery, query the table, and you can see the first row, and we only have ID and data column. Now, I'm going to change the table schema.
I don't know why it's still wrapped.
Here. I'm adding a new column, new double column. When I created these in here, maybe a little bit. Now you can see that there is a new double column also. Then let's insert a data new double column. Let's see what we have inside of Spark, right? We insert the two data. Then Spark should show us the both of them. Spark table. Now we are able to see that the same. If you go here, we are able to see that too. Yeah, this is my demo. And here with that, let me continue the presentation. Yeah, I just start with this particular shell, just with 4 parameters. Then I share the same comments on the presentation, then I also test it. And I also put the one additional things that we discuss about the data governance. In this example, I created a BigQuery table and the Iceberg table, and I just let the users to use a specific, the access policy for it. Here, as you can see that, take the role policy and filter that if ID is equals to 1, we are not going to show that. Up here. Then what is next? The PR is already merged. Thankfully, this morning, PMC is also merged Kafka Connect catalog. Then we are supporting the Kafka Connect also too. If you are using the Kafka Connect, you can use it. We are working on the 2 more things. Like one is that Trino support. Hopefully, the very close time we will bring Trino support also too, and multi-credential support. This is a kind of maybe a niche use case, like running on the same machine with the multiple credentials. You should be able to do that. Currently, we are just using your default credentials. You cannot use, in the same code 2 different credentials to access the data. And these are the next questions.
IAM is the storage level, not at the engine level.
So we have the row policy. So that's common across the engines. Is it like applied at the storage level so that any engine that queries BigQuery or Spark,
yeah,
gets applied?
if they are using the BigQMS, the BigQuery Metastore, it is independent from the engine. This is the whole life. But if you are, of course, if you are directly to read the tables on the GCS, then there is no any, the raw filtering or something.
Anybody coming via the Metastore is still bounded by those policies, irrespective of which engine issue there.
Correct. Yes.
Just a couple of questions. Here.
Oh, sorry.
So, yeah, so you talked about interoperability, right? So is it accessible outside of Google Cloud, or is it only Google Cloud?
Of course, we target our users, but it doesn't mean as long as you keep the your Google BigQuery Metastore inside of the Google Cloud, you can call access the different cloud provider also too. But from the other cloud provider, you have to use the Google credential to access the BigQuery Metastore.
I see. And second question, so do you have any plans to implement managed features like Tableau optimization as part of the catalog itself?
You're right. Thank you for asking that. I didn't mention that, but my focus was that basically Metastore. Actually, BigQuery also have the manage Iceberg table options. You don't need to do compactions or optimize your table. And also, BigQuery has a unique feature, kind of if you're a BigQuery customer, before my talk, I saw another talk like how you can do the streaming best practice. BigQuery provides a streaming insert for the Iceberg tables, and you can insert and immediately it will be available inside of the BigQuery. And if you wait, enough that it will be available also on the open source engine too. But if your use case is streaming specific, the BigQuery provided that manage capabilities inside of the BigQuery for Iceberg tables.
So one last question. So you mentioned that it's compatible. So is it really compatible?
BigQuery, there's a 2 flavors. One is that BigQuery is the manage the Iceberg. it's currently exposing to V1 spec, but we are working on the V2 and V3 spec support. For BigQuery is not managed table. BigQuery as an engine, the reading the Iceberg table, we support Alto spec, nothing is different.
We are at time now, and I know we have a pretty packed session, so I'd like to thank you for our presentation, and we have a field that's coming up next. So.
And I just want to say one thing, sorry for that. We are hiring, if you are into Spark, we want to hire you guys.